very little to unpack.
All right.
Yes.
Welcome to this month's Tech Lancaster, everyone. It is streaming as normal, so if you have complaints that you want to air, you might save them till the end or something. And it's a small group, so I guess we'll skip the calendar for the moment and just get straight into Francis's talk. So take it away.
Cool. Hi, I'm Francis Wertz, and today we're going to be talking about how Ada Lovelace hacked into Teddy Roosevelt's email to save us from World War Z. That's my drunk history opening. Yeah, so today we're going to talk about vertical slice architecture. I think when I originally pitched this, it was going to be about clean architecture. They go hand in hand. This talk will be very informal, casual, so feel free to interrupt me at any time, ask questions. I'll do my best to project and rephrase questions to one of these phones so that the live stream picks up, so I don't have to get that to yell or anything like that. Anyone here full stack developers? Do full stack work? Yeah? Okay. This will be primarily focused on full stack web dev. This could apply to really any technology, any platform. I've used this primarily in .NET, but I've used it in Node projects as well, technologies like Nest.js. You can architect this in pretty much any platform or stack that you have available to you. So just a real quick slide about me. Actually, this is the talk that I did last year for our developer education conference, so about 100 devs. There's a conference that goes on for about a week, and there's a handful of chats that happen throughout each day during that week, so I did a couple talks. I did one for the Elastic group here like a month and a half ago. Kind of followed a very similar format. I've been with Holman for just a little bit over a year. I'm a project leader there, so it's a mixed bag of some project management with project development. I do a lot of architecture, design work, work with BAs, work with tech leads, developers, kind of in the middle of all that. Outside of software, I'm a home improvement enthusiast, although I think you'd probably argue that I want to be a home improvement enthusiast, and I just start projects and never finish them, and then act like I'm enthused about finishing them.
I think that's the definition of enthusiast.
Sure, yeah. So it's more about like, I need to buy this tool to finish this, and then actually I found a better way, I need to buy this tool.
I mean, isn't that the whole point?
Yes, exactly, right. Just a way to acquire tools not to use. What's a Holman? So, Holman is an automotive conglomerate comprised of about 8 or 9 different sub-organizations. I work in our fleet division, but we cover everything from upfitting, fabrication, venture capital, insurance. Our fleet business is one of our largest businesses, which is what I'm involved in, as well as our dealer and retail and parts business. We have about 27 dealerships across North America, and we just got a point with Porsche for our second Porsche dealership down in Florida. But yeah, we're dealerships in Texas, Florida, Jersey, PA, California, Colorado. None of this is super relevant to the talk, but the group that I work with is formerly known as ARI. So we manage about 2 million assets in North America, with a partnership in Mexico at about 500,000. And then globally, we service about 4 million vehicles. So that's mostly through strategic partnerships, but a lot of them leverage our technology stack, and they have their own business that will handle the day-to-day operations of those assets. I work in the customer-facing application team, so our customers are primarily folks that drive those vehicles and folks that manage those vehicles in their company. So, when I say cable company, you think of the big name brand for that good company. We manage most of their assets, if not all. So let's talk about changing software. So enterprise software, which is primarily what I claim to write, changes quite a lot, right? Technology is always changing. We're always fixing bugs, licensing new tech, old tech's expiring. Partners change, right? We might change vendors for certain parts of our platform. And of course, probably the most frequent one is the workforce changes. People get assigned new projects, new roles. You have new junior devs join the team. You want to have them maintain projects. So it's very easy for software to change as well as the environment can change that would ultimately impact the life cycle of that application. And with all those changes, if your architecture isn't built to support that or guide your developers in a way to help them achieve what they kind of fell into the pillar of success, right? Then you can quickly have a debilitating project where developers are adding new features here one year, and then 2 years down the road, wow, we can't really add this new feature or refactor a new platform because of the way we built X, Y, Z, right? So it's always important to keep in mind to have architecture that's built to stand the test of time. And so today we're focusing a bit more on end-tier architectures or onion architecture. Specifically, this one's referred to as clean architecture, which I think is just kind of a rebranded onion architecture term. So I've been building applications like this for, I don't know, probably about 7 years now. Mid-20-teens is when I started really adopting this kind of style of platform. And I do this for all different sizes of applications. I'll typically start with building some sort of kind of transaction script where I'll put all my logic in one location, and then as time goes on, I'll refactor it out into their appropriate layers. Let's talk about traits of a domain-focused clean architecture. I'm just going to read off the slides here. So it decouples software concerns across several layers. And what I mean by that is, it's very easy for us to say, oh, we're going to integrate with this cool new partner platform because they offer X, Y, Z. We don't have to write any of that code. We don't have to worry about how we're going to build that. Great. We start slapping that code in there. If we just start throwing that code in there, you're creating a dependency in your critical layers, that really shouldn't be touching or related to that software at all. For instance, if you're going to implement, say you're going to integrate with Square, right? The software that you write to talk to Square really has no relevance in the software that you're building for your client or for your current business or occupation. And so this kind of layers, the concepts is concentric circles centered around what we call the core. And the core is comprised of domain-centric logic. So those are things like your core types, entities, your business logic, value objects. When I say value objects, I mean things like, say a VIN number, right? It's not just a string, there's components to that mean different things. So representing those complex objects, which present and serialize as more simplified objects and types and the things that are more well-defined. Those can live in the domain. And then the idea is that you push the behavior and the core logic into that core layer. So the application and the domain really hold this specific logic that makes this app function. Everything else on top of it is really a second-class citizen. It doesn't really matter all that much, right? The database shouldn't matter. The partnerships and the vendors that you work with, it really shouldn't matter. The view layer that you use, right? I know we all spend a lot of time architecting and building really cool React applications, but we weren't writing React applications in 2010, or if we were probably having a really great time trying to figure out how that was going to work. So, what are we going to be writing in 2030? Whatever we're building in 2030, the application and the domain should more or less be the exact same. There really shouldn't be much difference. So the idea is to build a core that's going to last the test of time. And so what we look to do is we push behavior in towards the core, and we also manage how our dependencies flow. So we're not, and that's really where it's critical, is we have to define proper abstractions in our core to know what our outside layers should really look like. And our outside layers are what are responsible for implementing those interfaces and those code contracts to establish what the dependency lineage looks like. And what we get from that is infrastructure that's easily mocked for testing, and also because we have that air gap and that isolation, we have a core that very easily tests for unit tests and all that kind of stuff. So a concept with this, though, that kind of adds on to clean architecture is something called vertical slice architecture. And it's kind of built on the same idea that we have a bunch of layers that kind of layer like a cake or an onion, but it slows down a bit on defining so many abstractions. Not focusing on like, well, I need to create this code. Where's this going to live? It's going to live in this part of the project or this part of the project. It kind of takes all that away, right? Like what's the saying? The two hardest things in software engineering are naming things and validating cache. So I kind of think that there's like a third. Is like, where do I put this file? I just created this. What namespace is that one? Where does that make sense? So that's why I think where vertical slice architecture really helps is you're actually organizing. I had a quote after this slide. Yeah, you're actually organizing your software around your accesses of change. What I mean by that is your features, your functionalities, your capabilities of that software. That's where you should be pivoting and grouping your like items. I'll show you an example here of a clean architecture solution versus one that's done with a vertical slice to give you a flavor. But harkening back to that topic about our software that changes is when you have a clean architecture with all these different files in different locations, you might have achieved perfect abstraction, but you're jeopardizing that project as it grows because that still requires a lot of discipline and understanding, right? I can easily right-click in this folder and go, new file. That's not where it goes. And so I think it's easier to think of when you're implementing new features as your accesses change, that those features should all be grouped together, right? If I'm building a full stack solution to serve some sort of response, right? The controller, the model, the validation, all stuff should live together in this project. So if I'm a maintainer coming to fix that problem, amend it, fix a bug, I know right where to go for that project. If I have to add a new resource, a new style sheet, whatever it may be, I know exactly where to go in my solution to work on that particular feature. And real quick, none of this is actually coined by me, so this is pretty much, not really verbatim, but an individual by Jimmy Bogard. I believe he's a Microsoft MVP. Really talented guy, builds a lot of really popular tools in Microsoft for .NET. Some of them we'll see today. Not AutoMapper. Mediator is one of his more popular ones. And he's also kind of invented the idea of creating vertical slices. And this concept's really nothing new, but he just packaged it up in this pretty vertical slice kind of name scheme here. So this is what it would look like if you had a vertical slice as part of your solution. So your solution would kind of logically lay out these different layers, and a vertical slice is just basically saying, feature is our cross-cutting concern. Across all of these boundaries, we're going to group all those things together. So we're going to group our layered implements by feature, and those are our change axes. We're going to organize these features around a request-response lifecycle. Again, that kind of depends on what you're building, but in web, they're going to be organized around the concept of a request come in, I want to deliver some sort of response, whether it's JSON or whatever image, something like that. And what's really helpful here is using a pattern called CQRS. Anyone familiar with that pattern, CQRS? Hear that? So it stands for Command Query Response Segregation. And it pairs really well with request response architectures because it basically, the system receives a request and just simply sends out on it's kind of like a messaging system. It sends out an internal request that says, I need a handler to service this. And that could be distributed, it could just be on the same exact chip, it could be anywhere. And so the idea is that that messaging system will send that request out and a response will come back specifically for that request and that request alone. And that's just a simple query, so that's the Q part. The command part is more or less the exact same. It's, here's a command, I want to send that out and I just expect a simple acknowledgement back. So if I'm going to update something, right, I would send out a command, get an act back, then I would send out a query and get the response back with the updated item. Or I could just update it in memory and send that back as well. And so the idea is here we've totally isolated, we have a gap between what our logic that handles our queries and a logic that handles our commands. And it allows us to push the logic that handles those pieces further into the application, into the core, into the handlers. And so the handlers typically are defined at the application layer or at the domain layer. And I have a really simple app that I vertically sliced architecture that I'll show you here after, I think it's a couple slides.
So quick question.
Yeah, please.
If your services were server communicate with that server, I'm making this very general.
So the question is, let me rephrase it, is you're saying that when the request comes in,
The core can decide who's going to
Sure.
service that for you.
yes and no. The core really doesn't care. Like I said, this is more of like an infrastructure kind of layer. So as the request comes in, right, the topmost layer that's going to interface with that would be like a controller, some sort of web server that we've built code around. That piece will register a dependency to then dictate where that message goes. So it's going to be responsible for wiring up.
So if you had multiple web servers on a site,
Correct.
would you have something in between the requester and the servers? So if one server's busy, then you
Yes.
get another server. So there'd be like a gateway or something like that?
Yes, more on like the hardware, like appliance side, where there'd be some sort of load balancer that would handle that. But each individual server, right, will be responsible for handling that request. I thought you meant like at that part. That could also be distributed as well.
Well, I was thinking
Right.
it allows multiple possibilities.
Correct, it does. Yes.
Okay.
Like, yeah, and the example you'll see today is just simple, one server just running locally. Any questions? Ben, do you have something? No. Okay. And so let me just get my train of thought here. Right. So what this allows for is, and one of my favorite things about this is the way that you structure the solution in your code and your logic. It pushes the behavior down into the handlers, which makes it very easy to apply your own internal clean code principles and better identify if your code's kind of smelly. Maybe you're doing too many things that are too similar in a couple of different handlers, or you can genericize them, and you can actually chain handlers. So you can have one handler handle the command that does the more generic thing, and then kick that off to maybe a more specific handler. So
Also be great for testing new code.
absolutely, yep. And I've done that quite a bit, where we'll partner with one vendor, and we want to partner with another vendor. We want to partner with both and use them in conjunction. So you have a generic handler that can then proxy up to both of those, or you can do like a failover. This one didn't work, so it must be in this system. So forth.
I've got a question on that.
Yeah, sure.
So if a slice handles a type of request, right? Is that
So the question is, a slice handles a request. The slices are more organized by a feature, right? So a feature could handle multiple types of requests.
okay? Sure.
So you could have a scope of multiple.
Okay.
Right?
So then when you're talking
Could.
about having a generalized handler, a generalized handler, is that only for one slice where it can use the handler in a couple different ways, or can several slices use the
Yeah,
generalized?
right. You can. So the idea behind CQRS is like at that point you don't really care so much about the vertical
Okay.
slices, right?
Yeah.
If the responsibilities spill over into the other slices, then sure, yes, you could incorporate that and use CQRS. It's really more about the request coming in though doesn't really know about any of that, right? So we're able to isolate that
Okay.
from other slices. In certain, I would say in certain circumstances, if you're using multiple things that would be considered other slices, there might not be other slices. You might be able to just collapse that code all into one slice, right?
Yeah.
But say perhaps, you know, if I'm maybe I have a request that's going to validate a purchase order. Well, that's going to also spill into updating an order. That could just be its own. I might just want to update an order, change the last name of whoever bought something, right? So that could spill into other areas as well. But the system will handle that. The idea though is that is isolated in its own slice, so that request response lifecycle lives its own axis. Yeah.
Cool.
You can claim it makes sense. I'm not sure if I'm.
No, that makes sense.
So yeah, let's get into some code here and give you a bit of an idea for what I'm talking about. I have two different solutions. I did have this one solution. It's like a simple weather validation app that I did have both versions, and I'm not sure what I did with. I thought I had a branch of the clean code one, so I don't know where that is, but I do luckily have the vertical slice one. I was panicking this morning trying to find this. I was like, oh no, but luckily I have the one that's important, which is the vertical slice one. So I'll show you an application that I'm working on now. We're actually beginning to architect this project and start to develop it. So this kind of relates to more what I'm doing right now, which is working with electric vehicles. And I won't get too into the details of what this project is, but it basically involves around people charge their EVs at home. That incurs a cost, right? And we want to be able to reimburse those people the money they spend charging a vehicle that's not theirs, right? If they work for a company that gives them a fleet vehicle, they want to charge it home. Great, you can do that. Plug it in at your wall, trickle charge it, whatever you want to do. We'll try to track that based on what we know about the vehicle, and then reimburse you a certain dollar amount. So this solution is all based around that kind of workflow process. So you'll see here, this is more of a clean architecture organization, and then we might refactor into something like vertical slices. This is, for the most part, a relatively small solution. So it's, how many projects we have here? 5 or 6 projects within this overall solution. Now the more test projects will come, but for the most part, I think we have most of our layers defined here. So working top down, this is an external project that will get moved out of the solution eventually. It's just new for this particular solution. We have our domain layer, which is going to house our core types. So we have a You know, we have some entities that live in the charging area. That's the primary kind of domain concern. We have our persons that represents both internal and external people that work at Holman or are clients of Holman. We have some rate stuff that we're still kind of laying out yet to determine electricity rates for certain areas. And then we have our reimbursement section to kind of map what a reimbursement looks like from start to finish. Those are our domain concern areas. And so we don't really have a whole lot of business logic in here yet, but we do have all of our types roughly defined. And so those types we're actually going to use as our entities for this project as well. And what's nice about that is in our domain, we're defining strictly, these are what our types are. This is core to this is crucial to how the application is going to operate and process its own logic. We want to base our database off of that. And so our persistence layer, which is next, persistence is just the same as like infrastructure. It's a very outer layer. This solution, 10 years from now, we're currently an Oracle shop. We've been an Oracle shop, and probably will be an Oracle shop in 10 years. But should we not be, maybe we'll switch to Postgres or who knows, Cosmos DB, who knows. That domain should be reflected in that particular infrastructure database. It doesn't have to be Oracle. And so that's what the persistence layer is there, is that's really to help us define what that infrastructure layer is going to actually look like, take action on our domain types. And so in here, most of this is just centered around a context where we have, and we're going to better organize this, but right now everything's just kind of collapsed into one large file. But the responsibility of the context is to take all of our core types in our domain and then map them correctly to our database so that our other layers in our code know how to operate using this database context. And from here we can generate, migrations and all that kind of stuff. But it's all very specific in particular to our Oracle database. I'll pause there. Any questions? Okay. And so I'll get into extensions. This is a language feature in .NET. I'll tap into that here in a minute. So the next layer is the reimbursement layer. So this is the application layer, right? This is kind of the higher layer of the core. This is where most of the critical stuff is going to be wired up. So this is where we're going to define things like our services, internal models that kind of span multiple types or very specific user actions. So in the application layer, this is where we're going to define our code contracts for our services, repositories, whatever types of entities that we're going to use throughout the actual solution. We're going to define the contracts here, and then we're actually going to define the concrete implementations here as well. And I'll show you how this gets wired up here in just 1 second. And again, this will very much parody our domain kind of namespace. We'll have a charging concern. Insights is our web platform. So it kind of follows that overall generic namespace of code types and not really features. And then we have our web project. So our web project, this is a Blazor solution. This is where everything kind of comes together. So our high-level layer, our view layer, is responsible for wiring all this stuff up. And so dependency injection is what really makes this possible. So we define in our application layer what our abstractions are, but what our concrete implementations of those abstractions are. And that goes for application software. So we've defined like our own state store, for instance. Actually, that comes from our domain. But we wire all that stuff up there to make accessible by a dependency injection throughout our entire application, whether it's a controller, a view, component, page, layout, doesn't matter. This is where it all kind of gets wired up. So you see here a couple different examples: state store, state initialization code. We have a couple different services here, so a charging service and then a program setting service. Then we have some configuration objects that we're going to define, which our vendor code will eventually consume. And so what this saves us from is, again, we're not necessarily coupling our web solution directly with our application. We're taking a dependency on it through these code abstractions. So if we decide to completely change how the program service works, if our underlying business logic drastically changes, yeah, we'll have to update our view, sure, but in terms of what we have to implement throughout the solution, it's very minimal. As long as our code contract surface stays exactly the same, the underlying behavior, as will be implemented in our application layer, and our view layer will operate just the very same. So a cool showcase, I don't really have anything to really show, but I can kind of speak to it, is after we do a scope audit, we typically will meet with our security teams, so in DevOps and our SecOps teams, to review our architecture and kind of talk through what a request response is going to look like. You know, especially Blazor is a new solution for us, so we haven't used it before, so it's kind of like a new thing. How are we going to deploy it? How are we going to secure it? And so a pattern we often follow in our .NET solutions is our API layer, the layer that integrates directly with our database, is privately networked. And then it's only allowed to access via HTTPS into our DMZ zone. So we don't have that infrastructure in place here. But what we easily do is basically treat our own API for this project as infrastructure. It's a second class, it doesn't really matter, right? And so we will define our code contracts the exact same way in our application layer that our API layer will then implement. And then we'll wire it all up inside of our web solution. And so instead of directly injecting services, we're not going to do that any longer. The services are not going to be isolated. We're not going to be able to interact with those services because they'll be deployed in their own privately networked area. We will actually then create HTTP clients that will inject in their place. But to the view layer, it doesn't matter. It's not going to know the difference between a concrete service that's directly doing entity framework calls or ADO calls or store procedure calls different from a service that's going to be reacting over, could be doing who knows what. It could be doing RPC calls. Doesn't really matter. So that's kind of a cool little win that we've already had to run into with this particular solution. And then lastly, apart from tests, nothing wrong with there. Lastly is our vendor code. So we're still playing around with a couple of different vendors, but the exact same concept. We define generic code contracts in our application layer, and then we implement those specifics inside of our vendor project, and then inject them into our web solution to consume. So should our vendor change for electric rates, like especially their folder called AMP Up, we don't even work with them anymore. That was like an initial scope consideration. They're totally out of the picture. But had we partnered with them and then changed stuff later, we could have just stuck with the same exact code contract, implemented a new SDK layer to integrate with the new partner, and then wouldn't have to change our application apart from that layer. Any questions on architecture? Seems like a pretty cool architecture. So vertical slice is intended to improve on that, not so much in I think an overall benefit way, but I just think how the structure is organized. And again, so just to recap for Ken, the vertical slice is focused around our axis of change, which are more or less just features, functionality, right? So in the last application, right, let's say a feature is we have to be able to read and edit the program settings. So as somebody who can admin their fleet, they should be able to log in and go to a settings page. I'm not going to run it just for. Probably shouldn't be too much about the solution anyway, so I'm not going to run it.
We never saw anything.
Yeah, never saw it.
It's only recorded.
Yeah, whatever. So that's kind of our axis of change, right? So right now, that all lives across several different projects in this entire solution. You've got interfaces and concrete implementations of that defined in one layer. You've got views defined in another layer, a controller for that, another layer. So separating all that out becomes a little tedious and confusing over time. And so totally separate solution, but I think we'll be able to bring it home. This is more of a vertical slice architected application. And just at the surface, it doesn't look too terribly different. This is a bit top-down versus bottom-up from the last walkthrough. So this is a weather application that I just basically took the default application that you can scaffold. I just created a new web API, and this is what you would typically get. And then I just over-engineered the hell out of it to be a clean architecture. So I think by default it serves up like static JSON. So I have the ability to, I think it integrates with the open weather map service or something like that. So we're actually talking to a real weather service. We want to be able to cache those responses, even though it's probably not, it probably gets the terms of use to do that. But for demonstration purposes, we can integrate with other infrastructure as part of that life cycle. And then as well as being able to validate when we enter our zip code, right? We'll proxy out to Bing, Google, some sort of vendor to validate, yep, that's a real zip code. Let's standardize that zip code before you send it over to the weather service so you can get a real weather data for a real zip code.
Using that
So
example, I have a question.
Sure.
So when you look at properties, Can one look at that as being an API or a set of sub-APIs that perform that particular action or service?
What do you mean by properties? I'm sorry, what?
It's one of your items up there on your
Oh
list.
yeah, this is just that's boilerplate baked into the.
No, but I'm trying to come up with an example.
Sure.
How is this, because I'm missing a piece.
Okay.
So this might help me understand how I'm missing
Sure.
a piece. So we're looking at properties, that's a set of services or actions to be taken. So that could be an API, under that there could be several other APIs that support that.
Sure. Yeah.
Okay, so what I'm trying to understand, and what I'm missing is how is that different than you would have done application 5 years ago?
I don't really think it's any different in terms of how you would, at the heart, implement it to service the request.
Yeah.
It really wouldn't be any different. I think it's more about how you would structure. So I 5 years ago, you could still easily implement it like this, but 10, 15 years ago, you might have just an overall API application that's just a monolith, right? So you have your controllers defined, all your APIs, and sure, you could organize them by overall type or concern, properties, weather, whatever, prices, purchase orders. You have all your relevant methods in there to handle creating new ones, editing them, about all that stuff. What's different about this approach is that you'd basically create several different controllers that would each be responsible, almost like microservices. It's very akin to like just building a microservice, right? Think of that as your feature. So the microservice itself, it's only responsible for just one part of what that overall API offering is. So your feature would be listing orders or listing properties, right? That would all live by itself. The validation for that request, lifecycle of that request, everything that touches that request would live together in a particular solution. And then you have a API layer which then coordinates all that to basically bring in and make it one cohesive experience. Or they could be deployed totally independent of each other as well.
Okay, thank you.
Sure. See, in this case, the API layer, there's not really anything defined here though that covers the topic of what an API is, right? There's some stuff that's very specific to this API, like there's a JSON middleware, so this just basically structures our errors that we get back from the application in a structured JSON format. It'll handle validation errors as well. Actually, that's what this middleware does down here. This is just a nice little formatter, very much a network response application or API concern. And then same thing down here, in the startup class, this is where everything's configured. So this is largely just a configuration project, and that's really it. It wires everything up. And you'll see here, we're using something called add application part, which is our get forecast controller. So in this case, our API, there's only one API in this project, but should we have more? Say we want to say we could control the weather. We could push an update, change the weather, right? That would be its own separate application part entirely, its own feature and functionality. All that stuff would live together there. So yeah.
All the endpoints kind of applied by wiring it up, so you're not
Correct.
defining like the Swagger API.
Exactly.
Put it against it. It's all kind of applied by the contracts.
Yeah. Yep.
Sorry
Well.
if I missed the fundamental piece.
No. That's really the question. So the question was just by adding the application parts together, is it make it implicit that that's how you like your Swagger docs would get generated? And the answer is absolutely yes. Yeah. So by means of using things like annotations in your individual application parts, once everything's registered together, that builds the cohesive experience that really to the end consumer looks no different if you were just to put it all in one big project. It could all be in one file. So yeah, there's really no visible difference at the surface level. So everything's wired up here. We're configuring configuration classes for the Open Weather service, the Open Weather API rather. We're not actually calling directly to Google, which I think is the service for address validation. There's a utilities project that I built some time ago that actually proxies that out. So we're calling that as our geospatial service. Register our caching, which is Redis in this case. And then right here, we add the Swagger docs. And then this is crucial here. This is actually using Mediator as part of this project as well. So this is actually wired up to use CQRS currently. And the way this is registered is basically we just give it a type in the assembly. It goes through and will automatically look at all other types that belong in this assembly that implement certain interfaces and register them in the message broker. And then we'll come back to this add transient line. That'll be a cool little final thing. Adding in some validation and a couple other options, and that's really it. So that's all the API application really is at this point. It's just a simple configuration project that wires everything up. And obviously takes advantage of all the ASP.NET features like adding Swagger docs, all that kind of stuff, and giving you one cohesive API experience. So the application layer, this is where we have our features. And so there's 3 primary features. Caching you can kind of call a feature, but we have our get weather forecast, and you're seeing here, this is where we have our controller defined, the request that controller uses, the response that you can expect back. Well, actually, this is an internal response, and then the configuration class. And then we have a get standardized request feature, very similar. There's no external controller for this. This is just simply the CQRS files, so the request and the handler. I grouped them all together just for readability's sake. The response, and again, another configuration class. Well, I'll come back to each of these. And then our domain, there's really nothing in our domain at all. We have the concept of what a weather forecast should look like. And then we have some utilities to do weather unit conversion. So this is kind of representative of what our business logic is. I don't really think I can classify science as a business logic. So in my test, I'm just validating that yes, we can indeed parse Kelvin to Celsius, should we choose. So real quick, let's jump to the weather. Let's jump to the controllers. That's kind of the first part of our journey in here. So I'm going to go down to the get forecast controllers. This is what's going to receive the request here. I guess before I jump into this, any questions? I'll bring into some more specifics, and I'll run this and show you. It's very underwhelming. So our first kind of part of this request here, and this will actually self-validate. So if we look at this get forecast request, because we added, I think it was in the API layer, we have the ability to add Fluent validation. It'll automatically do assembly scans and look for these validator classes and verify these rules all pass first, and then it will stop the request from proceeding and return a validation structured error should it not. So in this case, we just have postal code should be a minimum of 5 characters. We could obviously go into much in-depth validating postal codes. That's just a sample rule, and I'll show that failure. So that's kind of implicit, not really a concern of the controller. So the controllers really are kind of organizational layer, our marionette, so to speak, of this particular request response lifecycle. So the first thing we're going to do is send off a mediator query to get a standardized address for the incoming postal code. And we also pass a cache key and expiration should we choose to cache that particular query. And so what that's going to do is go down here to a get standardized request. So to answer your question, this is where we kind of jump over to a whole separate concern, right? So we could create a separate controller that just does address validation, right? Punch in a string, just I live here 208 whatever, get back a full object that represents your total address, right? So that could be its own separate feature, but we shouldn't isolate that feature from other features from using that. And that's where CQRS becomes powerful, is we don't have to couple the implementation of how we get a standardized address in our other features. We just pass off our request, and our own definition in the API layer will dictate where that goes. So this request here is going to basically construct an HTTP client, which is going to call our own internal API, pass along the address. That in turn is going to call Google and get back a response. We're simply just deserializing that JSON and then sending it right back. Nothing super fancy there. Back to the forecast controller. Next step, let's validate that we get an address. Let's make sure that it's at least a clean address that we get back. If we didn't get one back, we'll just kind of assume that's a failure. Our postal code he passed us, which is total gibberish. We have no idea what that is. So we'll elegantly fail there. And then should we have a good address, then we'll go on to build out our caching and request for the weather forecast. So again, very similar. We give that to mediator. Here's my weather forecast request. That lives here. It has its own validation. And down here's the handler for that, where similar pattern, we create a HTTP client and integrate with our open weather API. API to get that data back and just send back the final response, which is going to be the weather forecast with date, temperature, and a summary of what it feels like. So all that just to get 3 pieces of data back. Perfect, right? This is obviously heavily over engineered, and one thing I didn't really touch on too much was you shouldn't architect your solution from the get like this. But this is a pattern that provides a lot of success for a lineage of developers as time goes on. I originally built this application, I just had one controller with all this stuff in it. Everything I just did was just one large controller. And that's my transaction script. And from there, you start to break out your separate layers, run your tests, make sure they pass. Once they do, then refactor further, and kind of slowly achieve those layers rather than just try to jump all into it and get it right from the very start. And I've been thinking about applications and solutions and clean and vertical slice architecture for like 5 or 6 years now. So like for me, I just usually just jump right into it. But from an approach of having a monolith or having a new project, it's much easier to start simplistic and then slowly refactor into patterns like this. But what that ultimately nets you, especially with vertical slice architecture, is your features are very isolated from each other feature. You can develop and change them independently from other features. You can deploy them as microservices, should you choose. And most importantly, it allows you to keep what's important is your domain and application layers nice and separated from all the other aspects of your application. Now, obviously, the application has to be able to support stuff like dependency. Your registration layer has to be able to support stuff like CQRS and dependency injection. Those are pretty common, easy to find in most modern web stacks. Not too hard to find those particular concepts.
So you're building this as microservice, but it's kind of self-contained.
Right.
And then if you have other services that are kind of consuming, are you sharing data shapes, or how do things get shared between different vertical slices?
So the question is, how does data get shared between different vertical slices?
It's nice to have independent features. The features are only really interesting when they start to interact with each other.
Right.
To provide, the higher level value.
So there was just one quick. It's not really a correction. You kind of mentioned that the vertical the features, the slices, incorporate the domain models and stuff too as part of them. That's not necessarily true. So the domain is different, and that's the idea is the application layer takes a dependency on the domain, and so the domain objects are what would be more or less passed around between different vertical slices. Now, and that's I would say strictly on the domain layer. You would also define stuff like maybe some more complex types that maybe leverage the domain in your application layer. Those should be more isolated with your vertical slice and not so much being passed around. Right? So, right, exactly. Yeah. And so, like I said, pretty underwhelming. I will run this and show you. One kind of cool thing I want to show on Mediator, which I didn't touch on, and that's kind of the party trick of if you will, for this particular talk, is we didn't really get into caching that much. And so one thing what I really like about how Mediator does things is it makes it very easy to handle cross-cutting concerns. And what I mean by that is stuff like caching, logging, those types of things, right? Cache and validation. Those things kind of span multiple features. They don't really fit into one particular vertical slice. Multiple slices want to cache, but that's very quickly a code smell. You don't want to implement caching logic in each and every single slice. And so with Mediator, what allows you to do is actually define a pipeline that wraps an entire request response and axis of change. It wraps that entire process. It gives you hooks into that. So you can write more generic logic as a request comes in. Before it's processed, this pipeline, you can define that particular hook, jump in, okay, take the request coming in, maybe modify it, maybe just dump it out to a database table that we want to log for transactions, whatever you want, cache it, maybe do some additional validation. Any of those concerns that would be shared across multiple slices and you wouldn't want to replicate, you can do with a pipeline behavior, which I'll show you in just 1 second. I think it's Swagger, I forget what the endpoint is. Oh, I got the right URL. So here we go, Swagger docs with one with one API here, get weather forecast. We're gonna try it out. We don't need to pass a cache key or an expiration. We'll just pass in a zip code. What kind of zip code we want to use? The Grand City of Mountville. So execute that, and hopefully get back 200. Look at that. Feels like it's 25 point lots of digits of precision there. Celsius. Wind is moving to 2.6. I'm not sure what the unit is at 320 degrees. High is 26, whatever. Pretty unimpressive. But you see here, every time we call this, it's pretty snappy. But obviously, a concern is we might run into some rate limiting, for instance, right? So maybe we want to cache this. Maybe we don't want to. Maybe our licensing with Google isn't quite as robust as what it is with the Open Weather project. So we can run into some concerns there. So we want to cache some of this. So that's where we can add in the pipeline behavior, which I've defined up here as a separate feature. This is specific to Mediator, but this can wrap any request that implements a cacheable request. And so what we do is this is basically acts as a hook. Once the request comes in, both at the request and when the request returns a response, we'll check and see if that request is cacheable, and if it is, we'll run it through some logic here where we validate. Let's see if we have a cache key. If we do, then we'll basically try to suss out what that cache key or what that object was. I'm using Wertz currently. We'll deserialize it into the appropriate type and then just return that. So we're not calling to our underlying infrastructure. We'll just hit the cache. If we don't find it, we'll just do what's called a read-through cache action. We'll just go straight to the actual infrastructure underneath, which is represented by this await next. And then once we get the response, same thing. Once we have the response back, then we can choose to then cache that data in our cache, and then finally return a response. If it's not cacheable, then we'll just await and then continue. That's it. And so we can wire that up in our API layer with all of our other configurations. We'll just come up here and turn on. We'll register it, save it, restart. And now, as simply as that, we've added caching as a cross-cutting concern to all of our CQRS entities that implement that cacheable request pipeline. And all you really have to do is, I think you just implement an interface, and then it requires you to add a cache key property and a time span for when it should be invalidated and everything else, just behind the scenes. So we got a nice cross-cutting concern there across any part of our application that we would like. Now, visibly, there's not really going to be any difference. A little more I/O there, but now it's basically instantaneous because we're just hitting the cache, which is right above. All right, any questions on that? We can always come back to it. So let's get into some recap and some questions. So to recap, vertical slice architecture, it inherits a lot of principles from clean architecture or onion architecture. Separates itself by organizing the features and capabilities around your axes of change. And where it becomes really powerful is in implementing a pattern like CQRS, where you can separate and segregate your request pipelines from your command pipelines, and allows you to isolate and insulate your features and changes from each other, unless you choose that they interact with each other. But again, that would all happen through domain objects and domain value objects. And obviously, what's really crucial to this being successful is having some sort of dependency injection container that you can register all these services and abstractions to make available. And I also heavily use assembly scanning to do runtime registration of all these different services. But like I said, I've implemented this in Angular. I've done it in Nest.js projects. It's very transportable, this entire architecture concept. So yeah, it doesn't really benefit applications that are very small in scope, like the one I just demonstrated. Obviously, pretty stupid. You just have one particular, little purpose-driven solution. This is more meant for enterprise applications. Question?
I actually have a question.
Sure.
While the initial development and scope may not be that way, if you're trying to build extensibility into that for future things that you think will be coming down the line, then it would seem to me that would provide some value.
Absolutely. Yes, this architecture,
I've seen it countless times already. It's really great at insulating you from like business-driven changes. We need to change vendors or do this crucial part totally different, or just maybe amend it to include this. That would normally be a huge hassle to refactor an application to support those types of things, or you'd be touching way too many layers to implement what is a relatively simple change. You know, when you're in a meeting, it sounds simple, but then come in and implement it, touching a lot of different files. You've got to, you know, write a bunch more test cases. When in reality, your architecture can support a lot of that installation from the very beginning. But yes, definitely extensibility, all that is a big benefit. That's more of a clean architecture benefit, not so much a vertical slice architecture benefit.
Oh, they're using vertical slicing to implement it.
Exactly. Correct. Yes. Yes. Good question. Yeah.
Could you just throw that in Slack? Those links on those speakers without having to-
What's that?
Throw those on Slack if you want.
Oh, absolutely. Yeah. Absolutely. Yeah. Yeah. I can share this whole presentation. Yep. Yeah. So highly recommend. Really, any talk done by these two people. Jason Taylor. He works for a consulting company called SSW. They have a lot of great content on YouTube, and he has a couple of different talks that focus around clean architecture. Presents these topics significantly better than what I actually. And same with Jimmy Bogard. Like I said, he invented the vertical slice architecture, or at least that coined term of it. Excellent libraries for .NET on GitHub, all open source, very, very, very powerful stuff, and obviously he has really great talks as well. And some of these are just some other really cool .NET libraries, Meteors up at the top, Fluent Validation, those are two that I use in this particular solution, but I use some of these other ones as well, very frequently. And that's all. This concludes the ramble.
Let's give him a clap.
And that's how Ada Lovelace hacked in to Teddy Roosevelt's email and saved us from World War Zero.
Let me know when we're offline.
Oh, but an offline only question. Now we're getting the Tech Lancaster after dark.
Well, I guess we will conclude this then, and I don't know why I'm waving.
Until next time.
It's a good thing to do.